is a third example. And as you can see, this one is in terms of two trig functions, both tangent and secant. And again, we're trying to solve for theta between 0 and 360 degrees, 0 included. So suddenly it's not as easy as the other ones, or it doesn't appear to, because I have tangent and I have secant. So I can just say, oh, this is x, because then this one isn't x. So what I need to do is see if I can think about a relationship between tangent and secant. A lot of different steps you could take on this and you'll come up with the correct answer, but you want probably to look for the simplest and shortest. And so I see a tangent squared, and if I recall right, you know, if you think back, well, tangent squared, I think there was a Pythagorean relation that went along with it that dealt with secant. And that Pythagorean relation is that 1 plus tangent squared theta is equal to secant squared theta. So tangent squared theta, we could say, is secant squared theta minus 1. So we're going to use this fact to make a substitution, so our equation will be all in terms of one function, secant. So where the tangent squared is, I'm going to replace that with its equivalent name. Tangent squared is also known by secant squared theta minus 1. So we have secant squared theta minus 1 plus 3 equals 3 secant of theta. And at this point I look and see, well, there's some things I can combine, they're like terms, I might as well go ahead and do that. I have secant squared theta plus 2 equals 3 secant of theta. Secant squared theta, secant theta, now it's all in terms of one variable, in terms of one trig function. So this would be no different now than solving, this as being my x, so I'd have x squared plus 2 equals 3x, because x is representing secant of theta. This would be a second degree algebraic equation, and probably the first thing I try to do, since it's degree 2 or higher, pull everything to one side and get the other side equal to 0. It has to be equal to 0 if I'm going to factor or if I'm going to use quadratic formula on it. And then I'd say, okay, well, does this factor? And the factors are x and x. Factors of 2 that will add up to 3, 2 and 1, and they both need to be negative. And then we'd use zero product property, and we'd say, okay, if this times this, if this product is 0, either x minus 2 has to equal 0, or x minus 1 has to equal 0. And then solving, we get x equals 2 or x equals 1. And we'd have our solution. And again, we didn't do anything that would cause extraneous roots, so those are our roots. But our original was not given in terms of x. Our original was in terms of secant of theta. So we have secant squared theta plus 2 equals 3 secant of theta. Because we have a second degree, we want to get it equal to 0, one side equal to 0. That's an absolute must. And I'm going to put them in descending powers of secant. And remember, this is secant squared theta, and it means to take secant of theta squared. If it helps you to write it like that, go for it. So we have this squared minus 3 times that value plus 2. And so we're going to treat it like a quadratic. We're going to factor. Again, factors of secant squared theta. What times itself gives you secant of theta? Well, secant of theta, secant of theta. This is a good hint of what that's going to be. Factors of 2, that's pretty easy, 2 and 1. Signs, this needs to be a positive end result, negative middle term, so they both must be negative. And then we're going to apply zero product property. Since this is a product, either the secant of theta minus 1 is going to have to equal to 0, or the secant of theta minus 2 has to equal 0. Solving, either the secant of theta equals 1, or the secant of theta equals 2. Now, I need to think about when does secant equal 1? And if you think about secant, secant equals 1 when? Is it in a quadrant? Does it fall on an axis? Secant is the reciprocal of cosine, so it's kind of like saying, when does cosine equal 1, if we think about the reciprocal of 1? Well, cosine equals 1 at 0 degrees, and so does secant. So theta equals 0 degrees. Is there any place else where secant equals 1? Well, the secant of 0 degrees is 1. The secant of 90 degrees is undefined. The secant of 180 is negative 1, not 1, negative 1. And when we get to 270, it's undefined again. So that is the only angle that satisfies this. But we could also have theta equal to an angle, so when we put it in, we get the secant of theta equals 2. Okay? We know that that's not on an axis. It falls in one of the quadrants. And again, this is positive. So we're looking for where is secant positive, in what quadrants. And it's positive in the first quadrant. And secant, which is the reciprocal of cosine, is also positive in the fourth quadrant. So we're looking for when does secant equal 2. And we know that happens at 60 degrees. That's our reference angle. So theta could equal 60 degrees. But there's also another place where we'll have that ratio of 2 over 1. And that happens if we rotate around and stop in the fourth quadrant. And when we stop in the fourth quadrant, we have to stop so that this is a 60-degree reference angle. And so you ask yourself, how many degrees does it take to go around here and stop so that I have 60 degrees left? And we know that theta would equal 300 degrees. So our solutions, if we're looking for what angles will make this original true, our solution will be, that can happen if theta equals 0 degrees, 60 degrees, or 300 degrees. Again, through this process, we have not done anything that would cause extraneous roots. We haven't multiplied both sides by one of our trig functions. All we've done is done substitution and we've factored. Therefore, these are my solutions as long as I have not made an error in my work. So a good thing to do is put them back into the original and make sure that they in fact do check.